Hi, and welcome to Data 602 Advanced Programming Techniques. In this session, we're going to be doing a fairly quick overview of the NumPy library, Python library. So let's get started. Let's first start off with what is NumPy. NumPy is a Python library that has advanced array management. And that's what we're really going to be using for in this course. It's array capabilities. It also has additional capabilities for generating random numbers and Fourier transforms, which we're not going to be using in this class. If you want more information, I do urge you to go to the official website, which is numpy.org, and to also take a look at the NumPy source code at github.com/numpy. Now, why do we need NumPy? We already have some data structures that we've discussed in Python, like lists. Why do we need something new? Why do we need another one? Arrays, which are kind of like lists, are a way to map out and address data. And with that capability of doing that, you sometimes need to have some ways to generate those structures, manipulate those structures, and lists are limited in what they can do. NumPy has in its core a array structure called ndarray, which is what we're really going to be studying in this course. And the ndarray is like an array on steroids. It's extremely powerful. It allows you to do a great number of things very quickly. Now, one of the other advantages of NumPy is that it's written in C and C++, and then it's wrapped with Python, meaning that you can use Python, and it's written its interfaces are written in Python. However, when it does some of the heavy lifting and the ndarray related work, which you'll see shortly, it's then handed over to C and C++ to do that. And the reason for that is because Python is an interpreted language. That means that its code is converted into assembly or machine code on the fly or as it's running, whereas C and C++ are compiled, meaning that it's converted into assembly and machine code prior to running, so therefore it saves that overhead. In addition, C and C++ by its nature have certain features that allow it to be far more efficient than other languages like Python that are interpreted. Now, if you kind of are up to it and want to brave looking at some C code, below right here is a link to the source code for the ndarray. Actually, this is the starting point. You can jump into here and have a look and see what's behind it. If all you've done is use Python or R, then this might look a little scary. The source code might look a little scary. However, it's worth looking into and getting a feel of some of the guts of NumPy. Now, NumPy is used in other libraries that we will be using in this course, particularly pandas, but it's also used in another library called SciPy, which we are not necessarily going to be using in this course. And if you're familiar with pandas, pandas has a data structure called data frame, which leverages the ndarray. So it's important for us to learn about the ndarray first, and then we can kind of tackle the pandas data frame and be more equipped to understand how it's working underneath. So let's get started. What we're going to do now is jump into the Spider IDE and start looking at some NumPy code. So if you installed Spider using Anaconda, NumPy will automatically be installed. If you have not, or you are using a different IDE, make sure you have NumPy installed, and you do that typically using the pip installer, and just do pip install NumPy and you should have it installed on your computer. So let's get started. What we're going to do first is import the NumPy library. Just because we have it installed doesn't necessarily mean that we're able to use it in our script. We need to specifically ask Python to pull that library into our script for use, and the way that we do that is use the import command in Python, and then we're going to specify that we want to use the NumPy library. Now, in order for me to use the library, I just need to reference NumPy, and then by referencing NumPy, I can actually get access to many of the functions that it has. So once I type NumPy here and I hit the dot, this is going to open up a list of the different functions that I can use, and I really urge you to explore some of these, if not in the IDE, at least on the documentation on the website. Now, a quick way for me to, if I'm going to be using NumPy quite extensively, I don't necessarily want to type NumPy every time. What I can do is use an alias, An alias allows me to use the NumPy name. However, I can use a shorter version of it by specifying this alias, and this alias that I'm going to use is NP. NP, if you look at a lot of the source code that's out there that uses NumPy, NP is kind of the de facto standard alias for the NumPy library. So instead of typing NumPy, I can now type NP and hit the dot, and I'll get the same um, set of functions now. But however, I've just don't have to type as much as I did before. So let's start looking at some of the ways that we're going to explore NumPy. First, what we're going to do is kind of cover how we can actually create arrays. How do we create different kinds of arrays in the NumPy library? There are a couple of functions that we're going to look at that lets us do some cool and interesting things. And then we'll look at how we can reference some of the arrays that we made. How do we pull a particular item that's an array? NumPy also has this capability of reshaping an array, and reshaping means that I can change the dimensions of an array from one dimension to another dimension, and that's kind of useful, and we'll demonstrate that. Another feature that NumPy has is called broadcast. That's a very fancy word for a kind of a simple concept that we'll cover. If you're familiar with pass by reference or pass by value in some of the modern programming languages, or pointers in C, C++, a broadcast has something to do with that, and we'll look into that. We'll then look at how to modify values in a NumPy array or an ND array. If there's a value that I want to change or I want to update, we'll look at that. We'll look at some of the calculations that are kind of built in that can be performed on the items in the array. Then we'll look at the random library that NumPy has. How do we generate random numbers? We'll then transition into looking at the 2D array or a two-dimensional array or a matrix, which is kind of what you're going to be using quite a bit of. And then finally, we'll look at conditional selection, which is kind of a cool technique to be able to select certain items that meet a certain condition, kind of like an if statement. However, the way that it's written out is far more terse and efficient, and we'll demonstrate that. And that should give us a very strong overview of NumPy, at least enough for you to go off and to start playing around with this and exploring further. So let's start off with a simple function. We're going to use a function called ones, and ones creates an array for us that is just filled with the number 1, and I can specify how many items I want in that array. So let's say I want to have 5, and I'm going to assign this array that this function creates to the variable called a. And you'll see in the bottom here, I'm going to keep this here in the bottom instead of constantly typing the print command over. I'll just have this at the bottom, and this will print out the value that's held in the array, the type of that array that it is, and in most cases it'll be ND array, and what type of content that array has it's stored in the array. So these 3 things will be printing out consistently. So let's look at this function here called ones. What this does is creates an array of ones, and if we hit F5, we'll see that we have an array here filled with ones, and there are 5 of them. It's exactly what we asked for. And then we can see here that the type of this data structure is the NumPy ND array data structure, which we said was the array on steroids. And then finally here is the content. NumPy stores these numbers not as ints but as floats, in 64-bit floats. So that's something that we want to keep in mind. Now let's see, I can just explore a little more. Let's say I want to create an array of 10 ones. I can do that, and I can see that I have 10. So I'm able to quite quickly create a large number of values. If I want 1,000 of these, I can do that. And it's there, and I can create this array with values stored. These 3 dots here, if you see them, this means that it's kind of representing all of the ones that are behind here, and it's kind of a shorthand. There's a way to actually remove this, and the way to do that is we'll type something up on top, which gives Spider and NumPy some configuration information, which will be this print options. We won't get into why you need to do this or what this actually means. However, we'll just put it in here. So in case you want to see all of the values of an array, when we hit F5, we'll see that now we have the 1,000 ones in this one particular array. So just like we can do create an array of ones, we can also create an array of zeros. We use the zeros function, and let me just reduce this down to 10. And if I hit F5, I'll see that I have here an array filled with zeros. And let me just change this to 20 just for demonstration purposes, and I see I have an array of zeros with 20. And now I can quickly create these arrays that I might find useful. Let's say I'm setting I have a P&L table and I'm setting things to 0. This may be useful in that regard. There is another function here called I, and I here stands for an identity matrix. An identity matrix is a matrix with a equal number of columns and rows. And that allows me to create a kind of a 2D matrix with ones going down the middle along the diagonal. And I'll just show you that. And you can see this. This is called an identity matrix here. So everything else is 0 except these ones here down the middle, and the number of rows and the number of columns are identical here. So let's see if I change this to 10. I'll see that I have an identity matrix of 10 items. I can actually create a 2D version of the identity matrix by specifying a second dimension. So this would be, let's say, the rows, and this would be the number of columns. If I hit F5, I'll see that the ones actually end up here and the rest here are zeros. But this is not an identity matrix. This may be useful in certain cases, but may not be what this function is intended for. Now, the fact that I've created 2 dimensions here with the I function should indicate to you that I possibly could do the same thing with ones, and if you think that I could, you're actually right. So let's say I go back to the ones function and I run it here. So let me just change this to ones here, and I run it here and hit F5. I'll see that I have ones here. Now, what did I change? I got an error because I passed a 3 and a comma 10. However, what it's looking for is the values in a tuple. So unlike the I matrix, which I just passed in a pair of numbers, what the ones function here is looking for is a tuple which contains the rows and the columns. So if I actually remove this, I'm actually passing in 3 and 10. It's not going to work, but for the I function, it would work. This is just a bit of an exception to the rule here. The same thing for zeros. If I put in zeros, I do need to pass in a tuple also. So I'm going to pass in this 310 as a tuple and hit 5, and I'll have the zeros here. And let me just play around with this here. Do something like this, and I can see that I have a 10 by 10 filled with zeros. So these are now 3 quick ways I can create an array and fill them up with some basic values. Is there a 2's here? No, there is no 2's here. It's just zeros and ones, which we can, as we know in computing, we can kind of reduce everything into a set of zeros and ones. So we don't have a function here for 2's. That's not gonna be there. So let's go on to another function that we can use called linspace. Linspace stands for linear space, and what that lets me do is to create a range of numbers, an array filled with a range of numbers. So let's say I want to create an array filled with this here. So what's happening here is that NumPy creates by default 50 numbers that are evenly spaced from 0 through 15. So I'm specifying a range, and within that range it's creating 50 different equally spaced intervals and producing those numbers in an array. If I want to change the number of steps that it takes, and here it's producing 50, I can say, hey, I don't want 50, I want 5. I add an additional parameter and I produce 5 here. So I'll see that I have 5 here from 0 to 15. It's broken down into 5 segments. And this is useful if I want to break up a long list of numbers or a range of numbers into equidistant segments. This is an array that I can use fairly quickly and produce fairly quickly. And we also have the capability to create good old-fashioned arrays that we were used to using the arrange function, and if you remember from core Python, we use the range function in a for loop to generate a list of numbers. This is very similar, except that what it produces is an ND array and not a Python list. And so if I want to create an array from 0 to 15, I can see that it creates that here. And just like a list, the last number here is going to be exclusive, so it goes only up to 0 through 14. Now, I can also take a list. Let's say I do have a list here. This is the traditional list that I've used in Python. Let's just say it's these 5 numbers. I can convert this list into an ND array. The way that I do that is I use NumPy's array function and just pass in the list that I want to convert. And so when I hit F5, I see that I have 1, 2, 3, 4, 5, but the data type for this is actually ND array. It's not a list anymore because it's been converted from here. The minute I'm passing this into array, this list is converted, and this A here is now an NDA representation of these data items that were part of this list. This list still is intact and usable. However, we have a new data structure that has absorbed the values and created a new array. So I can always convert from a list and go to an array. So that kind of sums up the different ways we can create arrays. Now let's talk about how we can reference items that are in an ND array. Let's say I do have an array. Let's create an array here. Let's say I have an range from 0 to 50. And just let me eliminate this. And how do I access the items that are in this array? The same way I did with lists, the what's called the slicing notation. So I can say I want to do something like this. I want to print out A, and I want to print out 0 to 10, the items from 0 to 10, and I can see that it will print it out here. And it prints out the items with index number 0 through index number 10. And I still have the same kind of shortcuts that we discussed in the previous video, where I can start here, or I can start here and leave the right side blank. That means to go to the end, so it kind of starts from the 5 and then goes towards the end. And that kind of capability of doing the slice notation is still possible. Now if I have a 2-dimensional array, let's say I have an array where I'm making, let's say I have an identity matrix of size 5, and I want to access one of them, I can use this comma notation where I can say, hey, I want this element from this row and this element from this column, and if I execute that, I'll see that it's 0 here. So I'm looking for the item in the index row number 3, and with the column index number 2, which is, so I'll go 0, 1, 2, 3. I'm looking for something in this row, and then column number 2, it's going to be 0, 1, 2, and it's the 0 that I'm pulling up. Let's say I go up by 1 row. I'm just going to reduce this. This should show us a 1, so I hit F5 and it shows us that it's a 1. So what it's pulling is row number 2, which is 0. This is row 0. This is row 1. This is row 2, and then it's going to column 2. So this is column 0 here. This column here is column 0, column 1, column 2, and it grabs this one and produces this. So this is how I can reference the items in the ND array. Very similar to lists. Now let's talk about reshaping. Reshaping is a very interesting capability that NumPy has. It allows you to change the dimensions of an array. So what does that mean? Right now I have an array called A, and I can look at what the dimensions are by saying, hey, can you tell me about the shape of the array? So I use this property that this array has called shape, and I say, tell me about the shape. I hit F5 and it tells me that this array is 5 by 5. Right, and so what if I want to change the shape of it? I can do that, and NumPy has a a function called reshape. So I do something like this. Now notice that I'm not using the NP library. I am using the variable name, and the variable itself has a function, and I'm going to say, hey, I want to reshape you, and you are 5 by 5, so I want to reshape you into 2 by 5. Right now, this won't work because 2 by 5 implies that I have 10 items. 5 by 5 implies that I have 25 items, and this reshaping will fail. So I need to make sure that the number of items I have in here, which are 25, can fit neatly into the dimensions that I'm reshaping. So let's just say I do make this into a 6. That means I have a matrix that's 36, has 36 items, and I can reshape it to, let's just say 18 by 2. And I hit F5, and I see that I've reshaped it. So I had this 6 by 6, and let me just print it here. I have this 6 by 6 here, and now I reshaped it into something that has 2 rows and 18 columns, and this works because I was able to take all 36 items from here and just readjust them to here. Now obviously I can do the same thing. I can flip this around and make it like this, and see that I've taken this 6 by 6 here and changed it into an 18 by 2. So I have 18 rows and 2 columns. And the fact that I can reshape things allows me to take data from one place, readjust it if I need it for to use it or present it in a different way. I can actually I can do that. Now there's a way I can combine this with this. If I want to combine it into one step, I can just do something like this. So this is creating the 6 by 6, and then it's asking then to kind of chain, is a chain of functions to then change the shape. And if I print out A, which I'm doing in the bottom, I'll see that the results are the same. I have this 18 rows with 2 columns. So the ability to reshape, and let me just put this under the right section here, the ability to reshape the arrays is an important aspect of the ndarray capabilities. Now let's talk about broadcasting, and we'll do that by creating an array, let's just say from 0 to 12. And we have now an array from 0 to 12. Now let's say I want to take a section of this array. I want to take a segment of this array and assign it to another variable. I can do that by doing something like this, right? So I want item number 0 all the way up to item number 2, so I'm going to specify 3. And if I say print B, I'm going to see that I have a segment, or what's called a slice, of this original array. So the original array A here, I'm taking a portion of A and I'm assigning it to B. And then when I print B, I'll see that this is that portion that I've taken right here. This is B, and this is actually here is A. Now what broadcasting is that if I make any changes to B, if I'm changing any item in B, it will automatically change the corresponding item in A, meaning that underneath the NumPy code, what was passed over from A to B was a reference and not the actual values or a copy of the values. So let's say I take B and I say, hey, for the first item, I want to set it to, let's just say 100. And I go back and I print B here, and then I print A here. And let's see what happens. And I do this, and now what happens here is I see that I have 0, 1, 2, which is this here, this B here. I'm setting B to 100, and I print it out, and that's not a surprise. However, what is a surprise is that when I print out A, and I'm actually printing it out twice, the first item is also 100, and that's what broadcast is, meaning that B is broadcasting to A any changes that were made to it because it was kind of spawned out of A. Now, if I don't want to broadcast, what I can do is, the way that I do that is I use the copy function for the array. So instead of setting this here, what I'm going to do is I'm going to say, hey, give me a copy of A. Copy, what I can do is assign the values that are sitting in A and then give them to B without having or allowing B to broadcast to A. So let me just run that, and what I see that here is that B is identical to A. If I make a change to B, let's say I change the first value to 100, if the broadcast was enabled, A would have been impacted, but we'll see that in this case, A is not impacted. A is printing out here, and this is B here. For the first time, if I print out B again after the change here, like that, I'll see that after the change here, B has that 100 as the first element. However, A is not impacted. However, if I'm not doing this copy thing and I'm just slicing, I'm using a segment, then whatever changes I make to B are going to impact A. And we can see that here it's impacted. Here it's not impacted. A is not impacted. And here A is impacted. And this is called broadcasting. The reason we have broadcasting is that when you're copying and taking chunks of arrays, you don't really necessarily want to create a new array out of that. That can be a problem with memory. Every time you create new arrays out of existing arrays, you don't want to create a new structure in memory. You just want to point to the same structure. The negative side is that if you're making changes to that slice, it can impact the original array. In order to avoid that, you have to explicitly state that you want to copy. And imagine this array is, has 80,000 elements. What this type of copy might do to memory if you're doing this a lot of times, let's say in an algorithm. Whereas using a slice of it may be far more efficient if you're okay with the impact that the root array or the origin array is modified if the child array is modified as well. So that's broadcasting. Let's talk about modifying. We did a little bit of the modifying here. How do I modify an array? Let's say I have an array here. Let's from 1 to 30, go up to 29 when we print it. So I want to modify certain elements of it. We already demonstrated that I can change one element of it, and I'd say I want to change this to 100, and the first element changes to 100. Well, let's say I want to change more than one. I want to change the first 10 elements. So let's say I do that, and I do that, and I can see the first 10 elements are changed to 100. I can also change certain sections of it. Say I want to change not the whole thing, but something in the middle, and I can see that these here are changed. This is how I can modify a ND array. And with a two-dimensional array, which we're going to kind of cover, and we may already have touched upon, is I can specify, let's say I have a 2D array, I can specify the row and the column that I want to change, and then just change it to the number that I want to set it with. So modifying is kind of straightforward. It's similar to how we modify things in lists. So let's go on to some calculations that I can perform with an ND array. I can find the maximum and the minimum in an array. So let's say I have a range here. Let's just start with 5 and say 30. Say 5 and go to 300. And I run this. That, and I run this, and I have this. So let's say I want to know what the max in this is. We do know that the max is, it's the last number, but let's look at what NumPy offers us. I can use this max function, and I can say, hey, give me the maximum value, the highest value that exists inside of this array. And I do that, and it tells me the highest value is 299. Conversely, I can do the min value, and I'll get 5 here. That's the min value, and these is kind of some of the calculations that I can perform with the built-in functions that are part of the NumPy library. Now, another example that I can do is called argmax, which tells me the index number of the maximum item with the maximum value. Here, the item with the maximum value is 299, but its index number is 294. So if I wanted to refer to it, I can just use the argmax and get its quote-unquote address or its index number and pull that up. I can also do the same for argmin, and that's going to give me that the the index number, which is 0 for 5, because it's the lowest number in this array. Now what's also interesting is I can do calculations with the array against itself. So for example, I have the array A here, and let me just make it a little smaller. I can add it to itself. So let's say I do something like this, and I have an array that's going up to 9 with 10 elements. I can say, hey, I want you to print A plus A. I want you to print take A and add it to A. Now what does that mean? It's going to take each element and then add it to its corresponding element and combine it, and I get something like this, right? So basically I've kind of doubled it and multiplied it by 2. So this was the original array here, and by adding it to itself, I've kind of doubled each respective item, and I can do the same thing with, let's say, multiply. F5, and I can see that it's multiplied here. Let's say I do this, I want to do divide. I'm just going to change this to 1 so I don't get a divide by 0 error, and I'll change this here, and I see that I can even do division. So the number divided by itself is going to be 1, and I get all ones here. And I can also do something like an exponential here. I want to raise it to the second power, and I have this here. So I want to raise it to the 5th power, and I have this here also. So I can perform operations on these array quite quickly, and these arrays, because it's written in C and C++, these things happen very, very fast. You may not notice the speed difference if you're using an array of 10,000, even 10,000 items is a small array, but if you've got an array with millions of items, you will notice the speed difference when you're using these types of calculations. I can also perform a function or perform a arithmetic operation on the array. Just say, for example, I want to reduce each value in the array by 1, and I can do something like this. And this will do is take each item and subtract 1 from it, and I'll get something like this. And I need to assign it. So let's say it like this, and I get something like this. And we see that once I'm subtracted from each item, let's say I take this down to 10, I'm going to have some negative numbers, and it comes down to here. So very useful stuff. Now let's go on to randoms. There are a couple ways we can generate random numbers. It's useful to generate random numbers. It's packaged with NumPy because you may wish to have a matrix of random numbers that you might want to use to do some kind of testing or training, some algorithms or things like that, and you want to generate a matrix of random numbers. There's a couple ways to do it. There are a couple of different distributions that are used. First distribution is a distribution that's between 0 and 1. The library that I'm going to use is actually a sub-library of NumPy. It's going to be called random. I do NumPy and I type random, and now I have a bunch of functions that I can use that are related to using random and statistics. And we won't go into all of these. We'll go into like 1 or 2 of these, but let's say I want to produce a random number between 1 and 0. I would specify this function, the rand function, and 1. And so what I'll do here is say, hey, I want to store this in value b, and I'm going to print out b. Let's actually make it r for random, r, and I print f5, and there won't be an a here, so let's just omit this here for now. And I hit F5, and here is produced a random number between 0 and 1 that I can use. I'm going to hit F5 a few times. You'll see that it's producing a different number every time. If I want to use the standard distribution, I can use, instead of rand, I can use rand n, which gives me a standard distribution. And you can see here the values that are produced for a standard distribution, and the number of items here and how I want to reshape it is identical to how I used rand. So that's a quick overview of the random capabilities. We can demonstrate conditional selection by, let's say we come up with an array, and we go from 0 to 100. And let's say we want to identify which elements in this array are greater than 50. What we can do is do something like this. We can just say a equals a greater than 50, and we do this, and lo and behold, this array is transformed into a set of binaries and lo and behold, this has transformed into an array full of booleans. So all the ones that met this condition are marked as true, and the ones that didn't meet the condition are marked as false. So we wanted all of the values that were higher than 50. And we can see that the values that were above 50 were marked as true, and the values that are below 50 are marked as false. Well, the number of columns here are a little bit different, so you can't visually match it up. There are 17 columns here, and there are maybe 10 or 12 columns here, so you can't visually match it up to look at this 50 here. So this is a powerful way of doing a conditional, executing a conditional statement on every single element in basically one shot. I can also specify if I want a certain slice of the array here that is below a certain or above a certain value. I can use a certain conditional statement. So let me go back to my original array from 0 to 100, and I can say, hey, I want from this array, I want things that are really, let's just say, I want stuff that's under, let's just say it's bigger than 80, and put that back into the variable a. And I hit F5, and now I've got a subsection of this, and it's put into a into this variable a. I can actually easily have made it into a b, and I can put here print b. And using this conditional selection here, I can identify what portion of that array I want to pull here. And this enables me to perform a conditional selection on this array. So that sums up a quick overview of NumPy. It should give you a kind of a idea of the capabilities of NumPy. NumPy library is fairly large and extensive. It's not something you can learn over in 1 or 2 days, but this will give you an idea in terms of what its capabilities are. The other things that you may want to look into, there are a bunch of different functions that are that can be used with arrays. These are called universal functions. The URL for these functions are in the course materials for this week.